Avogadro's law is a law that relates, for gases, it's a gas law that relates the number of moles of a substance in a gas to the volume of the gas. And it's fairly obvious. You can just picture a balloon getting blown up. As you increase the number of moles, if it goes up, the volume of the balloon will get bigger. The volume goes up. So moles goes up, volume goes up. So that's fairly obvious, which means that we have a directly proportional relationship. So this should have one of those jumbled up formulas. You should have moles and volume working like that, in 1 times V2, moles of the gas at the beginning times the volume of the gas at the end is equal to the moles of the gas at the end times the volume of the gas at the beginnings. So, oh, I already said that, didn't I? Oh, there you go. It's a ratio law, so volume units must only be consistent. You don't have to use milliliters or decaliters or gallons or anything. Use anything you want as long as they're consistent. You can also use any kind of a mole, kilomoles or millimoles or moles or decimals, but you can't use grams. You got to use moles of some sort. So, our example of an Avogadro's law problem might look like this. 40.0 grams of fluorine gas occupy 250 liters. If 25.0 grams of fluorine gas are added, what will the new volume be at constant temperature and pressure? That was something I did not mention in the previous slide. Pressure or I don't think I did, I might have. Pressure and volume must be constant. You can't change the temperature. I said temperature and pressure have to be held constant. Obviously, volume is not held constant. So let's go ahead and let's start identifying things. So this is not moles, it's grams. So, but it's a number, so we're going to circle it. That's a volume. That is another number, and we want to know the new volume. So if we look and see what we have here, we have grams 1, we have grams added, we have volume 1, we have volume 2 is what we're being asked to find. Now, none of our formulas relate grams to volume. So you might get a little stuck here. Well, what do? There's nothing that uses grams. But we do have something that uses moles in volume. That's Avogadro. And even though these are not moles, they're grams, we can find moles from grams if we know the molar mass, which we do. It's fluorine. So what we're going to have to do is we're going to have to convert these grams into moles first. So we're going to have to take use the mole formula. What's the mole formula? The mole formula is N equals G over W. So we're going to have to convert this 40 and convert this 25. So, to find the moles of fluorine, we take 40.0 divided by the molar mass of fluorine. Now, fluorine is F2. It's a Hofbrinkel. It's a diatomic. It comes in pairs, so it's going to have double the molar mass you'll find on the table. So instead of 19.0, we're going to use 38.0 there. 40 divided by 38.0 is 1.05. But now we've got to do it for the other instance as well. So we do the same thing. We're going to do it a second time for the 25 grams. Since it's still fluorine, we don't need a different molar mass this time. We'll still divide it by 38. And this time we're going to get 0.658. So at the beginning we have so our moles at the beginning is 1.05. And our moles, be careful, that is our moles not at the end, but our moles added. They're added. It's not what we have at the end, that's how much we add. So we've got to be careful with that. So we're going to go use Avogadro's formula. Avogadro's law, and start plugging in what we just found. The moles at the beginning is 1.05, so I'm going to plug that in here. The volume at the end is what we're being asked to find. The moles at the end is not 0.658, that's how much we added to the 1.05. So what we're going to have to do is we're going to have to add those two numbers together, and we get 1.658. 4.71 using the rules of adding digits. And our volume at the beginning is 250 liters. So when we do this, our answer will be in liters because that was in liters. Our moles will cancel out, so we're going to now take both sides divided by 1.05 to cancel that. 1.05, so we're going to take 1.71 times 250 divided by 1.05, and that's going to give us the answer, which is 407 liters. The answer is 407 liters. That many grams will occupy 407 liters.